Hi everyone, I'm so glad you're here. Today I'll be sharing my insights into the next generation of AI, which I believe will be all on your phone. This is a deep dive into on-device model development at Instagram. So, what are on-device models and why should we use them? Today, a lot of people will be talking about training LLMs with billions of parameters and efficiently using billions of dollars of GPUs. While this is undoubtedly exciting, and in today's world, bigger is always better, I'm excited to talk to you about the other end of the spectrum. I'm Avni, and I'm the PM for the computer vision and machine learning team at Instagram, and we focus on-device models. Imagine a world where your smartphone understands you perfectly. Your smartwatch predicts all of your health needs, and your smart home devices respond instantly, all without ever needing to connect to the internet. This isn't a vision of the distant future. This is happening right now, thanks to on-device AI. On-device models are small, highly efficient models that are designed to run entirely on your phone, which unlocks the true scalability of AI without any concerns about GPU capacity. For you to really understand this space and how we got here, let's dive in to some history. The field of on-device AI isn't just evolving, it's exploding. Over the past few years, we've witnessed significant breakthroughs that have made it possible to run sophisticated AI models directly on mobile and edge devices. First, we have advances in hardware, obviously a huge prerequisite. The latest generations of mobile processors, GPUs, and dedicated AI accelerators like NPUs, which are neural processing units, and TPUs, which are tensor processing units, are designed to handle the intense computational demands of AI tasks. These advancements are making it possible to run complex models efficiently on your device with limited resources. Then, while hardware evolves, we have software evolving in parallel. This means that new frameworks and tools such as TensorFlow Lite, XecuTorch, PyTorch Mobile, and Apple's Core ML are enabling developers to optimize and deploy AI models more easily than ever before. These platforms are constantly evolving, adding new features and functionalities with every single update. Next, we have improved algorithms. So this work mainly happens on the research side. So this is research in model compression, quantization, and neural architecture search, which is yielding algorithms that are not only smaller and faster, but that maintain a high degree of accuracy. Techniques like pruning and knowledge distillation are more well known and are essential in adapting powerful AI models for on-device use. Then, growing ecosystem. This is a vibrant ecosystem of startups, established tech companies, and academic researchers that are all driving forward the state-of-the-art on-device AI. This is a collaborative effort across a bunch of different industries as the field really begins to grow. And then last but definitely not least, we have consumer demand. As users become more privacy conscious and as they begin to expect faster, more reliable performance from their devices, the demand for on-device AI capabilities continues to grow. This demand is pushing companies to invest heavily in developing and deploying these techniques. My team specializes in building these devices and the products that use them on Instagram. We started doing this work roughly 2 years ago when we saw the rapid development happening in the space and the unique value for Instagram of on-device processing. Since then, we've built a ton of products and made the creation flow on Instagram easier to use, richer, smarter, and of course, simpler. Now that we've discussed what on-device models are and how they came to be, how do we decide when we should use them, and if they're so great, why isn't everybody building them? To answer that question, let's dive into some of the key pros and cons of on-device development. Pros. 3 big pros. We've got latency, cost, and privacy. So latency. On-device AI processes your data locally, which means that your data doesn't need to be sent to the cloud and back. This leads to significantly faster response times and essentially no lag or delay. This means users experience smoother and more seamless interactions, improving their overall satisfaction and engagement. Then, cost. This is probably a problem folks here are intimately familiar with. Instead of paying for GPU server capacity, which can be prohibitively expensive depending on the use case, on-device models are free for the provider, since all processing is done on the consumer's phone. This makes these products more scalable, as they work the same for users all over the world, regardless of their internet connection or access to cloud infrastructure. Then, privacy. By keeping data on device, Ondevice AI ensures that sensitive information, such as your photos, remain private. Your data never leaves your phone, which makes on-device computing one of the most private and secure forms of AI. And now to the cons. There is one primary con, and it's a big one. It's model performance and accuracy. Obviously, to fit these big models into little phones, we need to compress them, which leads to some degree of loss of output accuracy. This is changing as models become more sophisticated, but in general, it is nearly impossible to deliver state-of-the-art performance on device when compared to server models. This means that the models we use on device need to be specific and tailored for the product use case that we're using them for. So now that we have a basic understanding of what on-device models are and why people use them, by the end of this talk, I will walk you through how to build these models and hopefully inspire you to get involved in the field. So how do we build these? I'm going to walk you guys through a pretty comprehensive end-to-end development life cycle for On-Device AI, and then link it to a product that we recently launched on Instagram. So here, overall overview of a product development cycle. And as we're talking about on-device today, we're going to take a double click into ML readiness. So ML readiness, a lot of different steps to make sure that your model is ready. But because we're focusing on what's different with on-device AI, today we're going to focus on model optimization and training, pre and post processing, and evaluation. So why are these different for on-device versus server models, and why is it a little trickier to make sure that they're performant? Now let's dive into techniques that make building on-device AI models possible. Given the resource constraints of mobile devices, it's important to use specific techniques to ensure our models are both efficient and effective. Namely, a lot of teams rely on model compression and edge AI frameworks. So for model compression, we either build the model on device first, or we start with a model that's been designed to run on the server and compress it. Model compression is essential for reducing the size of AI models without significantly compromising their performance. We do this through 3 techniques, although there are more. First is pruning, second is quantization, and the third is knowledge distillation. Pruning involves removing redundant neurons or weights from the neural network. This can significantly reduce the model size and improve inference speed. Then we have quantization, which reduces the precision of the model's weights from 32-bit floating point integers to lower bit representations like 16-bit or 8-bit integers. This decreases both the model size and computational requirements. Finally, we have knowledge distillation, which is when we train a smaller, more efficient model to mimic the outputs of a larger, more complex model. This approach retains most of the larger model's accuracy while being much lighter. And in parallel, in order to actually implement and build these on device in the most efficient way, we need the right infrastructure. So these tend to be frameworks that are optimized for mobile and edge environments like PyTorch Edge and ExecuTorch. So we talked about the overall training process, but that's only one piece of the puzzle, because now we have to pre and post process the inputs and outputs of that model. A strong approach to pre and post processing helps us mitigate the performance risk and ensure that AI models run efficiently and accurately on these resource-constrained devices. First, we have pre-processing. Pre-processing involves preparing the input data before it's fed into the AI model. Effective pre-processing can significantly enhance the performance and accuracy. Three techniques that are used for pre-processing are data normalization, data augmentation, and dimensionality reduction. This is all about making sure that the input is as uniform and as small as possible. First, we have data normalization. Normalization ensures consistency in the input, which is essential for the model to make accurate predictions. For example, my team often scales pixel values for images on device before inputting them into our models. Then we have data augmentation. This means changing the data in some way, such as rotating it, flipping it, changing the colors, to make sure that the inputs are standardized and that the model is robust and can improve its performance on a diverse set of inputs. Third, we have dimensionality reduction. This is reducing the dimensions of an input to decrease computational load and memory usage. For example, if you're processing a video and you don't need to process the audio, we could remove the audio from that input to make sure that input is a little bit smaller. Now, on the other end, we have post-processing. So this is ensuring that the outputs are as strong and as accurate as possible. A couple of techniques that we use here are output filtering, thresholding, and results aggregation. Output filtering is filtering the model's output to remove noise and to retain only relevant results, which can enhance the user experience. Thresholding involves applying certain thresholds to a model output, especially when the model's output is making a binary decision, such as yes or no. Setting a confidence threshold can determine whether a detected object should be considered valid in an image or not. Finally, we have results aggregation. So this means aggregating results across a variety of inputs. When analyzing videos, for example, sometimes we average our predictions over several frames of that video to smooth out temporary inaccuracies and to provide more reliable outputs. And evaluation. So you've trained your model, you've added pre and post-processing. How do you know that your output is good enough? How do you know that it's ready to be launched on Instagram or whatever surface you might work on? At Instagram, to uphold our quality bar, we perform extensive qualitative and quantitative evaluations throughout the training process. Qualitative techniques generally involve human review, while quantitative techniques usually involve machine review against a baseline or base data set. We really generally try to ensure that our evaluation is specifically tailored for the use case that we're using it for on Instagram, which is generally quite different from the conventional research evaluations. Instead of going after state-of-the-art performance, we usually prioritize for optimized for IG performance. This can be challenging when considering how varied and diverse the IG consumer base is, but we've developed a muscle over the past few years working on this that helps us really scale our techniques. So now that I sort of walked through the development process, let's talk about a real-world example. Here's a product that my team built last year, Cutouts. It's a new creative tool on Instagram, stories and reels, that enables users to cut out an object from any photo in their camera roll. You can see a demo of the experience here on the slide. This product uses a model called Squeeze Segment Anything, which is an on-device model that we developed. Before we get into the details, why did we decide to develop this product on device in the first place? Two big reasons. First is that the pros were really strong. Latency and privacy were really critical for a product like this, and we didn't want users to have to wait for a segmented version of their image for a super long time. We wanted the product and the flow to feel as seamless and as light as possible. And second is model quality. We felt pretty confident in our ability to deliver a high quality on-device model for this use case because it's relatively simple, image in, image out, and it's a capability that has existed on the server side for a while. I wanted to highlight this product because of its unique customer-facing nature and because of its evaluation technique, where we were able to compare the quality of the cutouts pretty easily. So here again is the three sort of buckets that I alluded to earlier in the context of this product, Cutouts. So for model optimization and training, we actually compressed a server-side model called Segment Anything, which is state-of-the-art model from Facebook AI research. Then for pre and post-processing, we experimented with a lot of techniques, but for pre-processing, we developed saliency models to optimize the user input to the model. And for post-processing, we used hole filling and edge smoothing to maintain our output quality. And finally, evaluation. How did we know that we felt confident about the product? So for quantitative evaluation, we used a metric called intersection over union to measure our performance against the state-of-the-art server model. And for qualitative evaluations, we manually evaluated outputs to gut check against quantitative evaluations and better understand our failure cases. So now that I've talked about a product that is not generative and uses on-device AI end-to-end, how does this fit in with the age of Gen AI? I actually believe that with the rise of Gen AI, on-device models will actually become increasingly important for checking and manipulating inputs in some way before they're sent to the server. In other words, I believe that on-device models are going to be a way to pre-process data for Gen AI models. 3 sample ways that on-device models can be used for pre-processing are data filtering, privacy preservation, and efficiency optimization. So data filtering. On-device AI can filter out irrelevant or low-quality data, ensuring that only useful and high-quality inputs are sent to the server. This reduces unnecessary processing and capacity usage. Next, we have privacy preservation. Sensitive data is something that nobody wants every AI model to have access to, but on-device AI can identify and mask sensitive information before sending that data to the cloud, which ensures user privacy. And third, efficiency optimization. Performing initial data processing on device can reduce the computational load on the server, leading to faster and more efficient overall processing. By integrating on-device models in your Gen AI pipeline, you can reduce latency for the user and processing costs for the business, which all leads to a more cohesive user experience and a more scalable product. So what's next? Is on-device AI going to be stuck in the pre-processing state forever? I don't believe so. In my opinion, the future looks quite different. I actually think that we can expect to see massive changes in the on-device space in the coming years. Remember when computers used to be the size of a room and now they're able to fit on your lap? I think we're going to see the same evolution for AI models, where now we rely on billions of parameters and billions of GPUs, and soon it'll be able to fit in your back pocket. This means that we will see increasingly powerful on-device models, which means that the functionality will expand beyond core computer vision tasks, which they're used for today, to large language models and more. I also believe on the consumer side, we'll see an increased focus on privacy and sustainability of AI. This means that consumers are going to be more concerned about their carbon footprint, as well as the security of their personal information when it comes to interacting with AI. And as a result, I believe that we will see hardware optimized for this use case. So more sophisticated chips that exist on your phone that are able to handle these sorts of tasks. Overall, I believe that the future of on-device AI promises a world where technology is not just a tool, but a seamless, intelligent companion. As these models become more powerful and pervasive, they'll revolutionize the way that we work, live, and play, making our interactions with technology more seamless, natural, secure, and personalized than ever before. Thank you so much for spending some time with me today and taking the time to learn about this exciting new field. I hope this piqued your interest, and I encourage you to get involved wherever you can. Thanks so much.